Well, so once the opening ceremony has been finished, we will start the technical presentations, and during the morning we're going to approach two of the blocks of the presentation of the works, the introduction of the works developed through the project. The first one is on technology transfer and innovation, and is coordinated by Carlos Campillo. Where are you, Carlos? Leave your mobile alone, your mobile phone alone. Carlos is a colleague at the CIFITEC site, which is the research center for the regional government of Extremadura. And it is one of the member institutions with the IFAPA as public research institutions in Spain. Apart from these, IFAPA, CIFITEC, and the one in Navarre, in the INTIA, the public research institution of Navarre. Apart from that, we had the University of Almeria and the Father Mark Foundation. I'll give you some information and reminding you some data on the project. As I was saying, this initial block is on technology transfer, and it will be coordinated by Carlos. Good morning to everyone. Thank you for coming. At this initial block, we're going to speak about a very important concept for us in the project, which is trying and seeing if the technology, the available technology, can help improving the use of sustainable water systems. We're going to analyze how technology works, how it is filling the gaps, or how it can be used to set up that aid for agriculture, and the rest of the way in which technology could help improving on the difficulties currently present. I will speak to you about how technology can enter into the different points. We're talking about different center related to water technology at different spots. In my case, for example, I'm a specialist in irrigation management. There are specialists in the management of algae, purification, etc. And another important side is the issue of the economic analysis of those technologies, what they are worth, their cost, and the possible contribution for the final farmer in terms of cost. And a very important part I will also mention is that of transfer. That is both Wim, who's coming from the Netherlands, from Wageningen, and Teodoro, who's from Almeria and who's a very good speaker. We'll talk about that transfer, how to improve that transfer, technology transfer, so it can be better used by farmers. I will start now by speaking to you about technology. It is very important that technology should solve problems. If technology does not solve the problems we have, it is no technology. A state-of-the-art mobile phone is worth nothing if it doesn't help in my daily tasks. So that technology won't be, it can be fantastic, but it's not solving my problem. Also, another important factor in technology, and about which we have spoken lots in Fertinova, is bottlenecks. Bottlenecks existing, appearing when farmers use that technology in order to be more efficient. That is, there will be a series of concepts or problems which will make it not so fluent for technology to work, and then gaps that devise the problems, preventing from an adequate solution to be available for a problem which has been found. How can we analyze and how can we get to know those problems? Initially, we worked with a survey, a poll. We asked a series of questions to farmers, and we prepared an inventory on the available technology. It was very important to know the technology available in order to see if it would solve the problems farmers would have in order to do a sustainable management of water. Once that technology was available, and as Els said before, it's been integrated into the fertigation Bible, that was an initial step, because farmers, technicians, engineers may look into the technology available to solve a specific problem. And once we have that technology, we've analyzed the problems of technology and we look into why the technology is not being used for the final handling, for the final management. And technologies from other sectors have also been looking into. And last, that technology and those sources have been used at different technology exchanges and demonstrations in the field. And which are the most important conclusions of these polls? First, it is critical, it is very important to look into water availability. It's a very important factor. Both the possibility for water to be there, to be available, and its quality. Most farmers used underground water, and there's a general trend for using alternating sources, rainfall, water from ponds, from small dams. I cannot really see the size from here. I wanted to refer to some items in the poll, in the survey. For example, there are a few curious things. There was an initial question we could ask ourselves. It is if the current legislation available in each country, it's a problem for sustainable management. And most people said that it was not a problem. So that can be discarded. And the main problem everyone found as an obstacle to handle irrigation is cost. The cost of technology, the cost of sensors, that's a big problem. Right, another important thing, I focus only on some issues I wanted to highlight. When farmers were asked about the tending of irrigation, we had to look to divide this into different kinds of farming: outdoor farming and greenhouse farming. Most farmers, outdoor farmers, did not use, were not intensive users of technology. It seemed that technified farmers are the ones working in greenhouses. And also in the management of fertigation, greenhouse farmers control fertilization, the amount of salt in water, in irrigation water, etc. Another important factor in the survey, when we analyzed these problems, these gaps, we have studied is that farmers do not, in many cases, find a logical reason or do not come across a problem when working in sustainability. When analyzing these gaps, these general gaps, it is very important to identify the specificities of technology problems. Sometimes it depends on the area, the region. ITs, for example, depend on the availability of infrastructure in the area. And sometimes it is not a technology problem, it is rather a problem, a side problem, a secondary problem. For example, education, social issues are important factor when alleviating technology problems. And also, it is very important to combine technology solutions with other non-technology solutions in order to improve that gap, that divide when applying water in a sustainable fashion. There's also an issue that farmers sometimes believe that they are using efficient irrigation, and they are not aware that there's a need for improvement, that sometimes they have reached sometimes a comfortable position and do not see the need for improvement. And also sometimes technology is not specific to the needs of the problems. Maybe the technology use is not adapted to specific needs of the farmer. Also, the survey showed that there was a need for further experience, for the development of experiences in the field. And of course, one of the problems is the lack of knowledge for farmers to do sustainable management. In this case, what we want effort in NUA is try and solve those problems and those gaps. One of the main gaps these years is the knowledge on the part of the technician, of the engineer. We believe transfer is one of the most important factors which can help bridge that divide between the application of technology and efficient management of irrigation. And of course, something very important is that of the adaptation of technology to farmers. Every single farmer should apply the technology needed at that specific moment. So that's why one of the main functions of the fertilization fertigation Bible is the availability of knowledge for farmers to adapt their work to their specific plot. This is a Bible, and it is very important when we speak about technology with farmers. It is very important that farmers do not feel swamped with technology. They should be helped to choose the most suitable technology for them. We cannot be talking about drones to farmers who have no meter installed at their plot. So farmers should know that there's technology, but there's no need to always look for the latest state-of-the-art technology. These are some of the conclusions. You have this information available at the Fertinova website. And this is on the technology gaps, technology divides we have found within Fertinova. We are specialists in different subjects. We have dealt with issues having to do with water storage, the lack of knowledge on the applications on specific soils, also problems having to do with legislation. Right now, Farmers Association in the northern part of my region in Extremadura, legislation said that ponds should be big enough to irrigate the whole of the area without the need to refill them. So this causes farmers building very large ponds. For example, in terms of algae, people are looking for long-term, low-cost systems, biological systems. And also looking into components such as chlorine, sodiums, and problems with filter clogging, and the issue of wastewaters. For example, in phytosanitary products, sometimes the cost of tests, some technologies are very costly, and sometimes they take time, and biological disinfection and problems with byproducts of chemical disinfection. And we've also detected that legislation is not standardized all throughout Europe. On the other hand, in terms of irrigation equipment, we see issues such as the need for application systems to be durable, cheap, and for example, we're working a lot in buried piping, and you need very good quality so drippers do not get clogged, the piping lasts for a long time, and also in terms of the preparation of nutrients, the issue of organic fertilizers, injection issues, all that is taken into account, and that systems do not fail. Well, with regards to irrigation, which is my subject, it is one of the main problems is that technology, you need to know technology. And it also depends a lot on the level of knowledge in terms of the management of that technology. I like using the example of a mobile phone. My girl, my daughter, deals with her mobile phone more than I do, and maybe that's going to be the generational change in terms of farmers, that farmers have that technology integrated. So there's more of a need of getting to know that. And technology, coming technology, sometimes companies have the technology but lack the agronomics, the agronomical knowledge, because maybe the technology is coming from the field of ITs or industrial engineering, but there's the agronomic touch needed. And in areas like ours, where there's outdoor farming, heterogeneity of soil is very important. So sometimes people lack knowledge on that heterogeneity. For example, if I'm going to put in place some probes, if I install it in a non-representative place, maybe I'm not going to have the right information. And then the use of decision-making systems, which let us look into what's available, both in terms of water and irrigation systems that should be available for plants, varieties, uses, etc. Then, in many cases, when data are gathered, they're not available in time for farmers to make decisions on time at the right moment. Then, with regards to phosphorus and hydrogen technology, in order to get rid of that, that's another issue. The problem of pesticides, which affects the whole of the European Union. And once we have analyzed all those gaps, we can identify technologies which are not being used, which are not being applied directly by the farmer or the engineer, and which may be coming either from the farming sector or from other fields in technology. The technology being used, this is a kind of a thermometer with different levels in terms of technology development, from the TLR9, which is the one available for entering directly into the market, down to the TR1, which is basic. That is what we have been analyzing out of a great variety of technologies, and you will count on a report from the Fertinova office. Last, I wanted to focus on this slide. I don't know how I'm doing in terms of time. I think I'm late. I just want to focus on this perspective. Farmers, when they want to improve efficiency in the management of water, they've got to understand it as a ladder. That means that the more I move through it, I've got to climb it harder, but I'm going to be more efficient. What's most important is that farmers or engineers are aware that they should go step by step. Because climbing 2 or 3 at a time will mean problems in terms of efficiency at a higher cost. So I want to show you that up to the drone issue, which can be today the technology or the issue of wireless sensor networks, there's a big step, and farmers may make a step forward. I'm sorry, we're having problems with the sound. Everything having to do with APPs, applications for irrigation management, the management of the crop, using free satellite images, sensor management for the modification of programming, down to the use of drones, which can be used for large areas. And that's very important. I think that's a very important factor. Also, I would like to tell you that technology follows a Gamma diagram. That is, in many cases they have very high peaks and the technology disappear. So farmers should select what they need at every single moment, because maybe drones are fashionable or certain technology, and then in a short time that technology will neither be available nor be used, because maybe I won't have analyzed if that's the technology, the most useful technology. And that's why we have built the fertigation Bible. And that's all. These are the different technologies we have been adding. For example, capturing water, harvesting water, underground water, and one of the technologies I believe in the last 2 years has meant a revolution is free satellite images, which let us look into a lot of information, especially outdoors, not in greenhouse farming, and it gives a lot of information what's happening. Thank you very much. Sorry about the time.